In this video, we're going to be talking about concentrations of solutions. Now, concentration, all it is just a ratio between the amount of solute and the volume of solvent that you have for a solution. There's a few different units concentration can be given in. The first one being mole per liter, percent by mass, percent by volume, or parts per million, which is abbreviated to ppm. So most of the time we are going to use molarity, which is that moles per liter units. Okay. So what we're going to be talking about in this next page here is just distinguishing between dilute and concentrated solutions here. So if we look at the two solutions we're given, both have the same volume of 100 milliliters of water. However, the difference comes in what we have for a solute. The reason why we know that sodium chloride, which is just table salt, is the solute is because in both cases there's less of sodium chloride compared to water. But if we compare the amount of sodium chloride in both, despite having the same volume, we have more solute in solution A compared to solution B. So because we have a higher amount of solute in solution A compared to solution B, while still having the same volume in each solutions, that means that solution A must be the more concentrated one. So then B is going to be less concentrated. Okay, or you could even say dilute. Now, in the next scenario, looking at the two solutions here, we have the same amount of solute in both. However, where the difference comes in is in the volume of solvent. So, looking at solution A, we have more solvent compared to solution B. And what this will mean is since we have less solvent in solution B, that's going to be the more concentrated solution. Whereas A is going to be the dilute solution. So if you think about this in terms of like mixing up some Kool-Aid, okay, if you mixed in 20 grams of Kool-Aid into 100 milliliters of water versus 20 grams of Kool-Aid in 50 milliliters of water, the 20 grams of Kool-Aid in 50 milliliters of water, that's going to have a much stronger taste compared to the other solution, simply because it's more concentrated. Alright, so question, which beaker contains a saltier solution? Well, in the first scenario, so the one at the top, that's going to be solution A, and then in the second scenario, that was solution B. Okay, so dilute and the terms dilute and concentrated, it all depends on the amount of solute and solvent that you're using in each solution here. In this next section here, they're giving us some directions to prepare some Kool-Aid. So it says empty Kool-Aid into a large non-metallic container and add 250 milliliters or 1 cup of sugar to sweeten to taste. Add 2,000 milliliters, which is 8 cups of cold water, and then stir well. So we're asked, okay, what is the solute? What is the solvent? So remember that the solute is just what you have less of. So in this case here, I'm going to make some adjustments here. Instead of sugar, we should just call this Kool-Aid powder to make this make more sense. Okay, And given that, now it makes a little bit more sense that the solute should be the Kool-Aid powder, because we have 1 cup of the Kool-Aid powder compared to 8 cups of water. So what we have less of is going to be our solute. Whereas the solvent, that's what you have more of. So that's going to be our water. Okay, and once our solute and solvent are mixed together, that's when we get a solution. Solution is just a combination of the solute and the solvent. Okay, question number 2. If the amount of water added was 4,000 milliliters instead, would the solution be more dilute or more concentrated than the initial Kool-Aid? All right, so let's compare how much solvent we had to begin with. So we started off with 2,000 milliliters, and now we're increasing the amount of water to 4,000 milliliters. So if we increase the amount of water while still keeping the same amount of solute, that's going to mean that this Kool-Aid solution is going to become more dilute because we're increasing the amount of solvent in the solution. And if you envision just making this yourself, if you have like a cup of Kool-Aid and then you pour more water into it, it's going to taste less strong than the initial like solution of Kool-Aid you had before you added in the water, right? And so that's another way that you could tell that it's going to be more dilute. Okay. For question number 3, if the amount of water added was 1,000 milliliters instead, would the solution be more dilute or more concentrated than the initial Kool-Aid? So again, we're just comparing our values for solvent. So 2,000 compared to 1,000. In this scenario, we're using less water to create our solution than we originally used. So less solvent while using the same amount of solute means that it's going to be more concentrated. All right, now moving on to molar concentration. Now, one thing to note is that molarity just means molar concentration, and molar concentration is represented in the units of moles per liter. So for example 1, it's asking us, what is the molar concentration of a 4-liter solution with 1.54 moles of sodium hydroxide dissolved in it? So when we're figuring out molarity, we're going to be using the formula concentration is equal to moles divided by volume. So let's just write out what each piece of this formula means before we get into calculating our answer here. So C is for concentration. It's going to be in moles per liter. N is moles, which is in the units moles. Sometimes I spell it as this just to get it down quickly. And then volume, V for volume, that's going to be in liters. Okay. All right, now back to the example. Let's write out our list of givens. Since it's saying what is the molar concentration, we have no clue what that is. Now it's saying that we have a 4-liter solution? Well, liters is a volume, so I'm going to say volume is equal to 4 liters. And then we have 1.54 moles. That's going to be moles. All right, so now that we have our list of givens, we're going to write out our formula and then plug in our numbers. So we have 1.54 moles divided by 4 liters. And when we divide those two numbers, we're going to get 0.385 moles per liter. The reason why it's moles per liter is because no units canceled out here. So that's why I'm getting that for units. And then last but not least, if we take a look at the numbers given to us in the question, both of these numbers here are in 3 significant digits. So just as a quick reminder here, trailing zeros, or zeros that come after a non-zero number, or sorry, a non-zero digit, are going to be significant. So that's why this has 3 significant digits. Okay, and same with this next number, 3 significant digits, because they're all non-zero digits. So if we look at our answer, it's already in 3 significant digits because the leading zero does not count as a significant digit. Leading zeros are just any zero that comes before a non-zero digit. All right, for our next example, it's asking us to determine the concentration when 0.23 moles of sodium sulfate are dissolved in 500 milliliters of water. So because it says determine the concentration, we have no clue what that is. For our moles, that was 0.23. And then for our volume, it was 500 milliliters. Okay, so just as a reminder here, looking at our formula, volume is going to be, it's going to have to be in liters so that our units for concentration can come out as moles per liter. So we're going to have to do some adjusting before we get to our formula. We need to convert our volume from milliliters into liters. Okay, there is a couple of ways that you can do it, but I'm just going to quickly write out the metric conversion line that I've talked about in previous videos. Okay. So with the metric conversion line, essentially what you're doing is you're just figuring out where you're starting and where you need to go to. So milliliters is going to be here. Remember that all of these letters here mean or are stand-ins for prefixes. So the capital T is for tera, G is for giga, capital M is for mega, then kilo, hecta, deca. The base units are any units that don't have a prefix, so that's going to be like your grams, liters, moles, so on and so forth. And then this is the prefix deci, centi, milli, micro, nano, and pico. So essentially what we want to do is figure out where we're starting, which is why I wrote this dot right here, and then figure out where we need to go to. So since liters is a base unit, and we know that because it doesn't have one of our prefixes attached to it, then that's how we know we want to go to our base units. And we start with where we're at, so milliliters, and then we count how many spots and in what direction we need to go to get the units that we want. So 1, 2, 3 to the left. So what that means is we're going to take the decimal in this number and move it 3 to the left. Whenever a decimal isn't explicitly written in a number, that means it's going to be right at the very end here. So 1, 2, 3 to the left, and I'm going to write this a bit neater here, so 0.500, and now we're in liters. All right, so now that we have the proper units for volume, I can get started with my formula. All right, so concentration, we have no clue, so I'm going to leave that as C. Moles was 0.23 divided by 0.5 liters. So when we divide those two numbers there, we're going to get 0.46 mole per liter. Okay. Now, looking at the numbers that were given, so 0.23, that has 2 significant digits. And our other number that we were given, that has 3 significant digits. So you always go with the number with the least amount of significant digits. So in this case, it's going to be 2, which I've already written my answer in 2 significant digits. Remember, leading zeros do not count as significant. So then this is done. So remember, for calculations, you need to include units, and you should always put your final answer in the correct amount of significant digits, and make sure you always wait until you have your final answer for your question to do any necessary rounding in order to get your answer in the proper amount of sig digs. Do not round your values early. Okay, what that's going to do is that's going to cause some inaccuracies in your calculations here. All right, so moving on to determining moles from volume and concentration. So I'm going to first look at our question, and then I'm going to show you how you can rearrange our given equation. So the question asks us how many moles are contained in 2 liters of a 4 mole per liter solution. So let's write out our list of given moles. We have no clue. We've got 2 liters for our volume, and for concentration, that was 4. All right. So now we're looking for something other than concentration here. So I'm going to start off with our formula that we've been using. And now what we need to do is we need to rearrange this so that we can isolate for moles. So what I'm going to do for isolating for moles is I'm going to ask myself, okay, mathematically, what is volume doing to moles? Volume is dividing into moles, so we need to do the opposite, which is multiplying. So I'm going to multiply this side, and what I do to one side, I need to do to the other. So volume multiplied by concentration is going to be equal to moles. And this is going to be the formula that I need to use for this question. So I'm going to start off, I'm going to flip this equation around. And now that I have that, we're just going to plug in our numbers and away we go. So we got 2 liters times by 4 mole per liter. So obviously 2 times 4, that's going to be 8. Now what's happening with units here is notice how we have liters on the top and the bottom. So since we have the same units in the top and the bottom, what they're going to do is they are going to cancel out. So what we're left with for units is moles. Now I've left a space here just to talk about significant digits. So notice that both numbers that we were given are in 3 significant digits. So that means our final answer needs to be in 3 significant digits, but I don't want to change the value from 8. So that means we have to go decimal 00, so it still keeps the same value, but it has 3 significant digits now instead of just 1. All right, so for the next example here, I am going to talk a little bit about unit analysis just in case you want to use unit analysis rather than a formula. The benefit of unit analysis is you really don't have to memorize any formulas. So what I'm going to do first is we're going to write our list of givens, see if we need to adjust any units, and then I'll talk about unit analysis. So the question is how many moles, so we have no clue what that is, of solute are in 750 milliliters, so that's our volume, of a 0.355 mole per liter solution. Okay. So I've left a space here because I'm noticing that volume is in milliliters when it should instead be in liters. Now, what we can do is we can use our metric conversion line. You can do that, that's fine. Or if you're not a fan of this, you would have to memorize the conversion factors between milliliters and liters. Either or is fine, just so long as you can do it consistently. So if you wanted to see how you could convert this using unit analysis, instead of using that metric conversion line, you always write your number, your given number, and then times by fraction sign. We want to cancel out milliliters to get to liters. So notice how milliliters is in the top. In order to cancel that out, we'd have to put it in the bottom. And then we want to be left with liters, and I'm going to put that in the only available spot left, which is in the top. And then you start with the bigger of the two units. So since liters is bigger than milliliters, that's where I'm going to start. And I'm going to write a 1 with the bigger of the two units. And so I'm asking myself, okay, in 1 liter, how many milliliters are there? Well, in 1 liter, there's 1,000 milliliters. So if you're going to do it this way, you do have to memorize the conversion factor with it, which is this part. Okay, so now what we're doing is 750 milliliters times by 1 divided by 1,000, and that's going to be 0.750 liters. So I'm just canceling out units there. All right, so now moving on to if you wanted to solve this question using unit analysis, we know that the units for moles is obviously going to be moles, and we're given liters and moles per liter to work with. So what I'm going to do here is I'm first going to start off with moles per liter. Okay. So I'm going to write the numbers in a second, but let's just focus on the units. So moles per liter, in order to get to moles, obviously I need to keep moles in the numerator. And the main thing that's preventing moles per liter from becoming moles is that we need to cancel out the liters. Now in order to do that, we need to multiply moles per liter by liters, so that we have liters in the top and the bottom so that they cancel out. So I'm just going to get rid of these brackets and we'll just fill in the numbers here. So we're going 0.355 moles per liter times by 0.750 liters. And as I showed you, liters are going to cancel out. And once we multiply those two numbers together, we're going to get 0.2662. The number keeps on going on. And that's moles. And looking at our given numbers, they're both in 3 significant digits. So if I count from the left, starting at the first significant digit, 1, 2, 3, so there's my cutoff line. So my final answer is going to be 0.266 moles. So if you look at both questions, ultimately we do the same mathematical process. We take concentration and we multiply it by volume in order to get our moles. Okay? Whether you choose to use a formula or use unit analysis is up to you. All right. So in this last example, we're going to be determining volume from moles and concentration. So just up in the top corner here, let's just talk about our formula again. Okay, so in these questions, we're going to be asked to find volume. So that means we're going to want to get volume by itself. The problem here is that most students, they just think, oh, volume's doing the dividing, so I'm just going to multiply by n because that's going to get the n over to the other side, which is incorrect. Okay. So when you're isolating for a variable, you want to get it in the numerator, so you want to get it up top, and you want to get it by itself. Okay. So when isolating for volume, in this case, it's going to be a little bit counterintuitive at first, but you just got to trust the process here. So volume is doing the dividing, okay? So that's why I'm going to multiply by volume instead of moles, because moles is not doing the dividing. That's why we can't multiply by moles. So we're going to multiply both sides by volume. So that cancels out there. And what we're going to get is volume times concentration is equal to moles. Now, where a lot of students get discouraged here is that they think, well, that didn't achieve my goal of getting volume by itself. But it's just a two-step process to isolate volume. So volume is multiplying concentration. Okay, or you could think of it vice versa. Concentration is multiplying volume. So in order to get volume by itself, we need to do the opposite. So we need to divide, but we're going to divide by concentration. We are not going to divide by volume, because if we do, that's going to bring us back to our original equation. Okay, and the goal is to isolate volume, so we got to get rid of anything that's outside of this circle. That's why we're dividing by concentration. So concentration cancels out. And if I write this all nice and pretty, volume is equal to moles divided by concentration. That's going to be our formula that we use. All right, now let's look at the question here. So what is the volume? So volume, we have no clue. When 0.500 moles of sodium hydroxide make a 3 mole per liter solution. So moles is 0.500 moles. And then concentration was 3 moles per liter. So I'm going to write my formula that I figured out right here. Volume is equal to moles divided by concentration. And then we're plugging in our numbers. 0.5 mole per liter, or sorry, just moles, divided by 3 mole per liter. So once I divide those two numbers, I'm going to get 0.1666. Number keeps on going on forever. Okay. And what we're going to get with units, it might be a little bit difficult to see here how we get the units that we're going to get. But let's just write out the units for a second. And I'm going to write this divide sign slightly differently, just so I can show you how the units cancel out. So this divide sign is turning into this divide sign, and then moles per liter. When you divide fractions, what you do is you go moles, and then you flip the divide sign into a multiply sign, and then you flip the fraction that comes after it, so liters per mole. Now you can see we have moles in the top and the bottom, so they cancel out, and that's why we're left with liters. So it's a little bit harder to see like why they cancel out over here, but this makes it a lot easier to see. So moles cancel out, and we're left with liters. Looking at our two given numbers, both of them are in 3 sig digs. So I'm going to count starting with the first significant digit on the far left. 1, 2, 3. There's my cutoff line. So I'm going to go 0.167 liters.